All right, so far we've been through all of the relatively straightforward KSP problems. It may not seem like it, but those were kind of the get to know you kind of KSP problems where we calculate a KSP value from concentrations, calculate a QSP and compare it to KSP. The common ion problems still are kind of in the relatively simple category because they're just modifications of a regular KSP problem. Now we're going to get into some meteor type examples. Now this first meteor type of example involves mixing of two compounds or two ions. So we're going to make a new solution. So if you mix 25.00 milliliters of 1.50 times 10 to the minus fourth molar Ca2 plus and 25.00 milliliters of 7.25 times 10 to the minus third molar F minus fluoride ion. Will a precipitate form? All right, so in order to solve this, we do need to know what the KSP is for calcium fluoride. And in the table, calcium fluoride's KSP is 3.4 times 10 to the minus 11th. Now this one is not quite as straightforward as the last one in the last video, because in that example, we had the concentrations known. Here we don't technically know the concentrations yet. We have two different solutions that we're dumping together. We need to calculate the concentrations after they're mixed. So we need to calculate concentration of Ca, 2 plus, in this solution. We calculate that with M1V1 equals M2V2. M2 is M1V1 over V2. So our initial molarity is 1.5 times 10 to the minus fourth molar. And there's 25 mils of that. Now we have 50 mils total at the end. So we're calculating the new final molarity of the calcium ion. Because it's the final concentration that matters, not what it was at the start, but after you mix them together. So the concentration is Ca2 plus. We calculate that. 1.5 times 10 to the minus fourth times 25 divided by 50. 7.5 times 10 to the minus fifth. And then we repeat the same thing for fluoride ion. So M1V1 equals M2V2, it's the same calculation, M1V1 over V2. So we plug in what we know for fluoride. Fluoride was 7.25 times 10 to the minus third molar. And we did 25 mils of that into 50 mils. Initial volume, final volume. Concentration of F minus. .625 times 10 to the minus third molar. So we know fluoride ion concentration and calcium ion concentration in this final solution after they're mixed. That's the important part, again, after they're mixed. So you do have to read these problems carefully. Is the problem telling you this is the concentration in the solution and can I make the solution without precipitating? Or am I mixing these two solutions and wondering if a precipitate is going to occur? There's a big difference because you have to account for that dilution factor in each one. Okay, so I'm going to move this board up out of the way for now, keeping in mind what our calcium and fluoride ion concentrations are, and we're going to calculate a QSP. So from calcium fluoride, it would be Ca2 plus times F minus squared. Because there's one calcium in the formula and two fluorides in the formula. So we plug in the concentrations that we just looked at. Calcium was 7.50 times 10 to the minus fifth. And fluoride was 3.625 times 10 to the minus third. And that one gets squared. So we type in 7.5 times 10 to the minus fifth times 3.625 times 10 to the minus third. Don't forget to square that. Equals, I get 9.86 times 10 to the minus 10th for QSP. We compare QSP to KSP. KSP from our problem was 3.4 times 10 to the minus 11th. So from these two values, we get that QSP is greater than, this time, KSP. That means that after we mix these solutions, a precipitate is going to form. So we cannot dump those two solutions together in that ratio and not have a precipitate form, because the value of KSP, which is a constant at any temperature, was exceeded by QSP. There's too many ions present, shifts left to precipitate some of those ions to maintain the KSP constant. Thanks, folks.